Hi, Simon. It's
Hello.
great to have you here.
Good afternoon.
Afternoon. I know it's not really afternoon for you yet, and it actually isn't for us. So thank you so much for taking this very early call with us to present to our audience. We do appreciate it a lot.
Okay, my pleasure.
So you're going to talk about the new features in Java and whatnot. And tell us, Timur, what is your favorite new feature coming to Java?
Well, my favorite feature coming to Java, probably it's Java records. How about it?
Yeah. Well, what makes it so special for you?
Well, to be honest, well, I can't use all the new features in production, but when I do my, for example, pet projects or something like that, in different languages like Kotlin or Scala, I really impressed about the opportunity of using data classes or case classes. So records is a feature is like something like this, and well, that is why I like it.
Makes sense. Okay.
So Simon, a quick question to you. I know that you are doing a great job giving different talks and running different webinars about the latest versions of Java. And it is 2 weeks ago when the latest version, Java 16, was released. And you managed to keep up with all the features. And I'm just curious how you can manage with this. There are a lot of new features coming every half a year, because with the new release cadence, we have a lot of different features coming from Java. And well, I just wonder how it is possible to keep up with this.
Yes, I mean, the good thing is that Java is developed in the OpenJDK project, and that means that you do have visibility of all the features as they're being added. And so the JEPs, as they're called, the JDK enhancement proposals, are made public very early on, and you can see which ones are going to be included in which release. And that enables you to kind of keep up to date with it. Also, being part of the Java SE expert group, they send me a link to all the details every once in a while, and I'm able to see things like the individual APIs that are being added, and so I can keep up to date with that very easily.
Nice. So in your expert group, what kinds or what parts of the ecosystem do you cover?
So it's Java SE. So I'm on the expert group for the actual Java specification, the thing that includes the Java virtual machine specification, Java language specification, and the class APIs. So what you actually need to call Java.
Well, so do you really take part in all of this, or is there some further subdivisions?
Oh no, it's the way that Java has been standardized has changed a bit. It used to be there was a lot more work that went on in the expert group. Now it's more about the expert group overseeing what happens in the OpenJDK project. So most of the development is done through the JEPs and the OpenJDK, and so the expert group is quite a small amount of work. There isn't a lot of detail to that.
Awesome, but still, it's impressive work, so thank you for it. And I guess you've got the whole talk based on your work, so yes. Let's bring it on.
Yes, we can't wait.
Okay, great. I'll take it away then. Right, so good morning, since that is still morning in Russia, and welcome to this talk. We're going to talk about how to get the most from modern Java. So as I was saying, we now have more features being delivered to Java more quickly than ever before. And one of the things that this has led to is the ability to include features but not make them part of the standard straight away. And this is very good because we can add things and get feedback from developers to make sure that these things are actually the way that they need to be for people who are going to use them. And this works in two ways. The first is what are called Incubator Modules. This is defined through JEP 11, so that's JDK enhancement proposal. And this is all about any non-final APIs and non-final tools. So it's APIs, class libraries, and tools that can be included. But the idea being that people can then provide feedback before they're made a formal part of the JDK as part of the standard or whatever. So an example of that was in JDK 9, we had the HTTP2 API that was included. That went through a couple of revisions, and then in JDK 11, it was made part of the JDK. The other thing we have, which is kind of related to that, more on the language side of things, is preview features. And this is very exciting because now, again, defined by JEP 12, what we can do is include new features. And this is not beta testing. This is not developing things as we go along. This is fully completed features, but where we want to gather feedback and make sure that what we're delivering is actually what developers want to use. So we can take that feedback and then make some changes if necessary, and then make it a permanent feature of the standard. So these two ideas are very, very good for developing Java in a way which means that we can shape it so that developers get exactly what they need. Now, one thing about the preview features specifically is that you do need to enable them. Because they're not part of the standard, you need to tell both the compiler and the runtime that you want to use them. So you need to use the enable preview flag, and then when you're compiling it, you also need to tell the compiler what version you want to enable those features for. So there's a couple of flags that you need to use. But other than that, it's very straightforward. And then this can also include some preview APIs as well if they're in the Java SE namespace, so Java or JavaX. Okay, so what I'm going to do is I'm going to go through all the features we've had since JDK 11. And JDK 11 is the current long-term support release as defined by Oracle and followed by all the other JDK providers. Let's start then with JDK 12 very logically. What did we get there which was new to Java and would make our lives easier as developers? And the first thing we got there was quite a substantial change to the language syntax itself. And this is what are called switch expressions. Again, this was introduced as a preview feature. So this is something that was added with the idea that we might make some changes before it became part of the standard. Now, if we look at how Java as a language works before this, we have a switch construct as a statement. And that's been there right from the very beginning. It's taken from the C language, the way that it works. And that's good, but it sometimes has some disadvantages which make it a little bit harder to use than is ideal. So for a start, we can see that every case statement needs to be separated. And then we also have to remember that for each block of case statements, we need to have a break unless we deliberately want to fall through into the next set of case statements, which potentially we could do. Most of the time, we don't want to do that. And if you're not using an IDE, I know IDEs nowadays put this in for you by default, if you'll excuse the pun, but certainly if you're using an editor like I used to do when I started programming in Java, it's very easy to forget to put a break statement in, and then you drop through by default, and suddenly you're getting a bug which is difficult to find. The other problem with the switch statement was the fact that local variables, the scope of those variables was not always as intuitive as you wanted to. Now, if we look at the way that we would typically use the switch statement in Java before, this is a very common idiom. We take a variable called day and we want to switch on that. And effectively, we're doing a sort of multi-if-then-else type of construct. And the goal of this is to assign a value to a different variable, number of letters. Here we can see that when we switch on day, we do case Monday, case Friday, case Sunday. We set the number of letters to be 6. Case Tuesday, number of letters to be 7, and so on. Very common use of it. But as I say, there are a number of points here where it's the case where you might make errors. So forgetting the break statement, but also forgetting to assign number of letters a value. Because if you don't do that, again, you get sort of weird errors that come up and might be difficult to find. Now, in JDK 12, what we have is the idea of a switch expression. The difference between a statement and an expression is with the expression, you can assign a value from that to a variable. With a statement, you're just doing something. With an expression, you're calculating a value, determining a value, and then assigning it if you need to. We can see that the code here is much simpler. Now we have the case where we've got a number of letters and we're assigning it once to the result of the switch expression. This is very good because now we don't have to remember to put that assignment in all of the different cases. So we're avoiding that potential problem. We can see also that the developers of this feature have realized that there is this thing called a comma-separated list. I must admit, it takes. I can't believe it's taken this long to figure out that you could use a comma-separated list for the case statement. So we can do case Monday, comma, Friday, comma, Sunday. We don't have to repeat the case every time. What they've then done is reused some of the syntax from the Lambda expressions, and we have the arrow. And on the right-hand side of the arrow operator, that's the value that's going to be returned from the switch expression. So Monday, Friday, Sunday is 6, Tuesday is 7, and so on. If need be, you can see in the default, we can also throw an exception where we've got a situation that doesn't have a value associated with it. So we need to do something, and we'll just throw an illegal state exception from that. Compared to the code we had before, this is both much more reliable and much more readable, much more concise, and just makes a whole lot more sense. One of the things that the developers also did was that they decided you could mix the old style and the new style syntax. And here we can see that, again, we're using it as an expression. So we are assigning the value from the switch expression. But now we're still doing the case Monday, case Friday, case Sunday. And in terms of determining the value we want to return, they decided to use break as a way of doing that. So you can break 6, and that will return 6 from the switch expression. This will work because the syntax of a break also allows you to break to a label. So you could break out of the switch statement and jump to a label somewhere else in your code. But a label can't start with a number. So that will work, and that's all fine. Another thing that was included in JDK 12 was an extension to the existing Streams API. So there was a new collector that was added, and Streams and Lambda expressions are a very powerful feature, giving us sort of functional style of programming to the way that we do things. And so making a few tweaks to this and adding a few new APIs is really good. And this is one I quite like here. So what they've done is add a collector called teeing. And teeing takes 3 parameters. It takes 2 collectors and a by function. And you can see in the diagram that I've put here, this is how it works. So we take the input stream, and that input stream is duplicated into 2 parallel streams, and you pass each of those streams through the 2 collectors that you specify as parameters to the collector. So what we do is then take the results of those collectors, pass them as inputs to the by function, and the result is what we get from teeing. Now, that looks a little bit complicated, so let's look at an example of how we might use that in real life. What we can do is we can take a stream of numbers, in this case 145217. We'll pass that stream into collect, and we'll use teeing as the collector. In terms of the parameters I'm passing here, the first collector we're going to use is summing double. So all that's going to do is take the numbers on the input stream and add them up to give us a total. The second collector we're going to use for the other parallel stream is counting, which will simply count how many elements we have on the input stream. The by function takes those 2 values, the total of the input and the number of values on the input, and then just divides one by the other, and it gives us the average of those numbers. Now, could have done that with just one method call, but it gives you an example of how you can use this, and clearly you can do more powerful things than this if you want to, in terms of calculating the values in this way. So I think this is a good addition to the Streams API. Okay, moving on to JDK 13. One of the things you find, obviously, is that depending on how much is being developed and how many features are coming to completion, some versions of Java will have more in them than others. So let's look at JDK 13 now. In this case, we have another language change. And again, this is a preview feature, meaning that it's not part of the standard and it's still got time to be modified and some changes made to it. In this case, what we get is text blocks. And the idea here is that in Java, we have strings and we can manipulate those a lot. We do that all the time. But the problem we've always had right from the very beginning is the fact that strings in Java are one line, and it's very difficult to construct a multi-line string. You have to use escape characters, you have to concatenate strings, and so on. Now, with text blocks, we have the ability to specify a whole set of text, including line breaks, and not have to worry about all of the way that gets put together. The way that this works is by using, rather than a double quote to indicate the start and the end of the string, we use 3 double quotes to indicate the start and the end of this string. As you can see here, we've got a string which we're going to call web page. We have 3 double quotes there. And importantly, you have to start the string on the next line. So you can't start the string directly after those 3 double quotes. You have to start it on the next line. We can see we've got some HTML tags, and we've indented those to indicate the structure of our HTML. We have 3 double quotes to terminate the string. If we wanted to put 3 double quotes inside that string, obviously we could do that. And if we want to do that, all we have to do is escape at least the first of those double quotes with a backslash. You can escape more than one if you want, but you have to escape at least the first one. If we print out the results of that, what we'll see is not exactly what you might expect. Because if you think, well, okay, we're going to take everything after those 3 double quotes as being part of our string, you might think that because it's moved over to the right-hand side, that we would include all of the justification on the left as spaces for our text. But that doesn't work. So what actually happens is that we're dealing here with what's called incidental white space. What we'd like to be able to do is, as we see in the code above, indent the string that we're creating more to the right-hand side so it lines up with the code that we're generating. But we also want to make sure that the indentation works in the way that we've got it here. So our HTML tags are indented correctly. So incidental white space is all the white space up to the start of those 3 initial double quotes. When the compiler compiles this, it's actually going to strip out all of that incidental white space for each line in the string. So we see here that all of the tags that we have are left justified and indented correctly. I think that's a very good thing to do. What we can do is we can change that a little bit if we want to. So we could add the 3 double quotes, put it on the next line, but then shift those 3 double quotes over to the left-hand side a little bit. What that will allow us to do is to have both intentional white space or intentional indentation and still have incidental white space. And the result of this is that if we wanted to have our tags indented by 4 spaces, then we can do that by shifting those 3 closing double quotes over to the left by 4 spaces, and then that makes it intentional white space versus incidental white space. One point to note here is that the way this works is because you have to put 3 double quotes on the next line, you end up with an additional blank line, which you might not want. So that's something to bear in mind. Switch expression. Now, of course, when you look at this, you'll think to yourself, well, hang on, we've already talked about switch expression. Why are we talking about it again? And the answer is that this is a great example of how preview features work, because a lot of developers looked at this and they said, okay, we get that you want to be able to use the old style syntax with the new style syntax and making it an expression, but we don't like the way that you're using break with a number, because you can use break with a label, and it could be very confusing in terms of trying to understand, is that break with a value, break with a label? The developers of this feature looked at that and they said, okay, that makes sense. We will change it to help developers so that it makes it easier for them to use. And rather than use break, we will use yield. So now we've got a different word being used, and it just makes it a little bit clearer that now we're yielding the value 6 rather than breaking. I think that's, again, it's a good idea, and it also proves the power of preview expressions. Moving on to JDK 14. Now, JDK 14, I think, is one of the bigger releases. JDK 12, JDK 13 had a couple of things in it, but JDK 14, a number of features came in that really changed some of the way that we can use Java in a powerful way. So the first of those was already mentioned before we started the presentation about records. So let's look at how we do a simple data class in Java. All I really want here is a tuple. I want 2 values encapsulated into a class so that I can pass it around as objects, manipulate the data in that way. This is all good. Very typical kind of thing that we do in Java. But the problem is, if we look at the code here, first of all, we have to define a class called point. Then we have to define that it has 2 instance variables, a double X and a double Y. We'll make them final. Then we have to have a constructor. So we've got point passing in double X and double Y. The body of the constructor, all it does is assign the value of the parameters to the value of our instance fields. And then we've got two accessor methods so that we can get access to both X and Y without making them public. Very typical Java code, but looking at this, just to create a tuple, you've got 14 lines of code. And that's really, rather excessive in terms of a simple thing like this. I always find it amazing, and I've had this discussion with Brian Gertz before, always find it amazing that there is a tuple class in Java, but it's buried way down in one of the libraries, and it's not really something you're supposed to use. It's not like java.util.tuple. I really wish they had that, but now they put records in. I don't need to worry about that. So records is a new language feature. Again, it's a preview. So we're seeing lots of preview features being included here, and we'll start to see in a moment how some of them do become full features. Now, in terms of our point, we don't need to specify all those 14 lines of code. What we do is we say this class called point is going to be a record. And what we want to have in that record is a double X and a double Y. Because it's effectively a class, we have a set of braces, but we as developers don't need to specify any of that extra code. We don't have the constructor, we don't have the accessor methods, don't even need to specify the instance variables. That is effectively the same as the class we saw on the previous slide. So if we want to use it, we can use it in exactly the same way. We can instantiate it, we can put it in a collection, we can pass it around as parameters and do whatever we want with it. Now, there might be situations where we need to do a little bit more logic in the constructor. And so they've introduced what's called the compact constructor. Here we can see we've got a record called range. And again, it's a tuple, so it's got two values, low and high. This time, in terms of the constructor, we want to put in a conditional to make sure that the value of low is not greater than high, because that would be kind of illogical in terms of range. To do that, we can use the compact constructor and say public range within the braces of the record. And we don't need to specify the parameters to the constructor. So we're eliminating that extra code. Reason being, because on the line above, we've obviously got the values. We know it's int low, int high. Then within the body of the constructor, we can have our conditional. We can test to see if low is greater than high. If it is, we throw a new illegal argument exception. Great. So we've got the logic that we needed. There are a number of additional details that we need to understand with records to be able to use them in the most effective way. So the first is, when we look at that compact constructor that we saw on the previous slide, the compact constructor can only throw unchecked exceptions. The syntax definition for that constructor doesn't have any way of being able to specify throws and a checked exception. So it just doesn't work that way. Again, this is one of those things that was discussed a lot on the mailing list, and it was discussed in terms of the way that feature was developed. But ultimately, the developers decided not to be able to specify checked exceptions for that. So all you can throw is an unchecked exception, like illegal argument exception or null pointer exception. Because we're dealing with a class here, you may want to override some of the methods in object. Object is the superclass of all classes, so we may decide that we want to implement different logic for how we represent our record as a string, or how we generate the hash code, or how we determine whether one record is equal to another record. So you can override those methods, but other methods in the object class you can't override in a record. So again, it's a slight restriction there, makes it slightly different to the normal class. Now, one of the things is that records are a class, but they are an extension of java.lang.record. So the base class of all records is record, and that means that you can't have a record that extends another class. You can implement interfaces if you want to, but you can't have a record that extends, your own class. All of them extend from record, and that's fixed. This is very similar in many ways to the way that enumerations work. Enumerations are a special form of class, kind of like a restricted class. Records are just the same approach in terms of that. Records don't follow the Java bean pattern. Now, this was, again, something that got discussed a lot on the mailing list. And so we have the idea that for the accessor methods, we refer to them just by the name of the variable, like x, rather than using the idea of get x or get y. This is one of those things that if you ask 100 developers which they prefer, you'll find 50 will prefer one, 50 will prefer the other. My personal preference, I like get X and get Y, but that's not a big deal. So that's just the way it works. You can't add additional instance fields to a record. Only instance fields that you can have in your record are the ones that you specify as part of the record definition. So the X and the Y that we saw above. What we can't do is then have our record and add another instance field Z, which we want to use internally. That just will not work. Records are all about data classes, so you specify the instance fields as part of that record. However, if you want to add static fields to a record, then you can. But obviously, a static field is shared between all the instances of that record, but it's not an instance field. And the last thing is that because, again, we are technically a class, just a special form of it, we can use generics. We can have generic type parameters that will all work very nicely with records. Next thing included in JDK 14 was related to the instance of operator. This was a feature included right from the very beginning of Java. What it allows us to do is to test a reference that we have to an object to determine if it is a specific type. There may be a method where you're passing in something which you don't really know which specific type it is. So let's say you pass in an object reference and then you want to be able to use it in a specific way. What we do is something like this. We say if obj instance of string, so we're testing to see if the type is string. If it is, then in order to use it as a string and call the methods on it, we have to assign it to a string reference and do an explicit cast. We create our variable s, define it as a string, and then we assign object to that, but we cast it as a string. So we know that s is a string, that all works. Then we can print out the length of the string, and that compiler will be quite happy with that. In JDK 14, they introduced pattern matching for instance of. Once again, it's a preview feature. And when you look at this, you think pattern matching. But don't get confused by that. This is not pattern matching in the sense of regular expressions and doing that kind of thing. This is pattern matching for patterns in the way that we code. And there's some interesting ideas for things that are going to come in probably JDK 17 and even later that will extend this even further into things like switch statements, switch expressions, and so on, and records. But in this case, what we're doing is we're looking at that and saying there is a very common pattern that we use for instance of, which is when we test against a variable, we have to assign it through an explicit cast. So what they've done is to say, okay, let's simplify that and say if obj instance of string, but then we'll specify the name of the variable that we want to be able to use that reference as s. We don't then have to have the line which does the assignment with the explicit cast. Within the true branch of our if statement there, s is a string, so we can reference s, scope is valid, and we can call the length method on s, and everything will work. In the false branch, because we've failed the test of obj being a string, the scope of s is not valid, and so we couldn't use s at that point. So s is restricted only to the true branch at that if statement. We can be a little bit more sophisticated with that, and what we can do is we can say that obj instance of string s, and then we can include an AND operator and also test to see if the length of s is greater than 0. This will work and is quite valid because in the AND operator, we know that we always evaluate the left-hand side, and only if the left-hand side evaluates to true do we bother evaluating the right-hand side. That means that the instance of must be true that we have a string, so we assign a value to s, and then when we evaluate the right-hand side, we know that the scope of s is valid, so we can do s.length and test against greater than 0. That will compile. If we were to try and use that with an OR operator, that wouldn't work, because in the case of the OR operator, we have to evaluate both sides, because if either side is true, then we pass. But in this case, that won't work, because if obj is not a string, s won't be valid in terms of scope, and then when we try to evaluate the right-hand side, that won't work because s isn't valid. So we can't do that. Sometimes the scoping of these values can be a little less than intuitive. So we could do this, and we could say if not O instance of string s and s dot length greater than 3, we return from that method. At this point, we know that because O is not an instance of string, we will have failed, so we will have returned. After that, therefore, O must be an instance of string, so the scope of S is still valid, and we can continue to use that S reference for as long as we like. Text blocks. So this went into a second preview in JDK 14, and they didn't really make many changes to that, but again, based on some feedback, what they did was introduce 2 new escape sequences. So the first of those is to say that we could include a backslash at the end of a line of text, and that would eliminate the new line operator or new line character that you would have got in terms of the old style of doing this. This is very familiar. If you've done shell script programming, or if you've done make files, then you'll be familiar with the idea of using a backslash to extend onto the next line. What this also does is it very nicely solves that problem of the extra blank line that we saw before. So if you put a backslash at the end of the last line, and you put your 3 double quotes on the next line, and you use it to change the intentional versus incidental white space, then you can eliminate that problem with the blank line that we saw before. So that's really good. And then the other thing that they did was they added the idea of \s, which doesn't strip the white space from the end of the line as well, which is what happened before. So now we can include intentional white space at the end. Helpful null pointer exception. This has to be my favorite feature of JDK 14. It's probably one of my favorite features of more recent releases of Java, because in Java, we have the concept of a null pointer. If we don't have a reference to an object, it's a null. Okay, great. But it's very easy to end up getting a null pointer exception. I'm sure that anybody who's written more than a few lines of code of Java will at some point have had a null pointer exception. That's fine, except that we do end up with situations like this, where we chain together references and we say a.b.c.i equals 99. Fine. When we run our code, we see something like this: exception thread main, null pointer exception, and it refers to the line where that happened, line 5, and we can see, okay, it was a.b.c.i equals 99. Our problem is, at that point, we don't know where is the null. Is it that A was null, so we couldn't reference B? Was it B was null, so we couldn't reference C? Or was it C that was null, but we couldn't reference I? Okay, we then have to either use the debugger in our IDE, or we have to break that line up, or we have to put print statements in, and it's just way more complicated than it really needs to be. So now, in JDK 14, after some 25 years, we've finally solved that problem. Now we get exception in thread main, Java long null pointer exception, cannot read field C because a.b is null. We immediately know the problem is that a.b is null, and so we can trace back and figure out where did we get a.b from and why have we set it to null. Fantastic time saver. The only criticism I have of this, and I'm sure I'll hear about this, is you have to enable it. Why? Why do you have to enable something as helpful as this? And when you enable it, you have to use this very catchy, very easy to remember command line flag, which is -XX plus show code details in exception messages. They probably could have made that longer, but it would have been hard. Moving on, JDK 15. Again, we are seeing changes to the Java language. This is one of the things I think is really great, is that there are lots of small changes to the language syntax of Java itself. And this is really helpful in terms of, especially as some of the OpenJDK engineers say, they're taking some of the rough edges off the language and just smoothing out some of the things that we do a lot of. If we look at Java, it's an object-oriented language, meaning that we can have inheritance and we can define type hierarchies. How we do that in our example here is we create a class called shape, and then we can have 3 subclasses from it: triangle, square, and pentagon. But the problem, if you like, that we have is that we have no real control over who can subclass from a given class. The only thing that we can control is by making a class final to indicate nobody can inherit from that. But in the class of our shape, we've decided triangle, square, and pentagon are suitable subclasses of that. But anybody else who's using our code could decide, oh, I like shape, I want to subclass that and make use of it. The problem potentially with that is if it's somebody who's using code from a different library somewhere else, it's a jar file, if we change the implementation of shape, which we can do because we understand triangle, square, and pentagon, it might be that that has a big impact on somebody else who's then subclass shape and doesn't know about those changes, and suddenly their code starts working in a different way. In JDK 15, we now have the idea of sealed classes. And once again, it's a preview feature. Everything now is being added as preview features. What sealed classes allow us to do is to have control over which classes can subclass a given class. So we already have final, and you can think of final as being the ultimate sealed class. Nobody else can subclass it. It's completely sealed. Now, one of the things about this is that although it is called sealed classes, it also applies to interfaces. Certainly, when I looked at this initially, I thought to myself, wouldn't it have been better to call this sealed types? But I posted a tweet on this, and Brian Gertz came back to me, and I think it might have been David Dallas came back and explained this. And he said that the reason is that although it could be called sealed types, interfaces are technically a form of class. So the decision was made to call it sealed classes. So I learned something new there. I didn't realize that interfaces were technically a form of class. So how this works is by introducing some contextual keywords. And this is actually something that's quite important because in Java, we have a set of reserved words, things that you can't use as variable names. Things like int, instanceof are examples of that. And because we're making changes to the language, what we don't want to do is to introduce new keywords in a big way, because that can have a very large impact on backwards compatibility. We have seen this a couple of times in Java. JDK 1.4 introduced assertions, so assert became a keyword, and in JDK 5, with the introduction of enumerations, enum became a reserved word, and that did have an impact on backwards compatibility. To get around that, in the past, we've used the idea of restricted identifiers and restricted keywords. In JDK 10, with the introduction of local variable type inference, var was made a restricted type, a restricted identifier, which meant that in JDK 9, you could have created a class called var with a lowercase v, but in JDK 10, you couldn't. So it wasn't a reserved word in the sense you couldn't use var as a variable name, but you couldn't create a type called var. Now, what they've done is introduce this idea of contextual keywords, where you can use them as keywords, but only in certain places. And that means that you can still use these things as variable names. For sealed classes, there are three of these. There's sealed, permits, and non-sealed. This is, again, a big thing because it's the first hyphenated keyword in Java. And a lot of people are sort of, the discussion about this, is it a good idea or not? I think it's a good idea because it means that it opens up a wider range of keywords to us. Key thing here is that hyphens are not valid in variable names, so there's no impact in terms of backwards compatibility. For sealed classes, all of the classes involved must be in the same package or module. And that's quite a sensible thing because it means that you've got visibility in a reasonable local space of the classes that are taking part in this. How this works is that we modify the way that the definition of a class works, and we can add some modifiers to that. Now, in the case of our shape, we can say public sealed class shape, and then add a permits clause to that, which will list a number of classes that are allowed to inherit from shape. So we permit triangle, square, and pentagon, and our type hierarchy will compile and be quite happy. If somebody else were to come along and say, I want to use that and make a circle as a subclass of shape, it's not listed in the permits clause, so the compiler will reject that and say, no, you can't do that because it's a sealed class. One of the things that's very important about how sealed classes work is the way that the inheritance and the capabilities of the subclasses must be specified. So the inheritance capabilities of each of those subclasses must be explicitly stated. You can't just leave it as a class. What do I mean by that? Well, there are three possibilities in how you can do that. The first is that you can continue to make the subclass sealed. In our triangle, we can say public sealed class triangle. Then we can again have a permits clause, which says that equilateral and isosceles are classes that can inherit from triangle. And we still extend shape. Second option is we could prevent any further subclassing by making that class, in this case square, final, so nobody can inherit from it. And then the third one is that we can effectively turn off the sealing of the class. And in our pentagon class, we can say public non-sealed class pentagon extend shape. So now anybody can inherit from pentagon without any restrictions. But you must specify one of those three things for any subclass of a sealed class. When I did this presentation a while ago, somebody pointed out a little thing which I thought was quite funny, which is contextual keyword humor. We can define two variables, one called non, one called sealed. Assign value of 2, value of 1. And then if we really wanted to, this is valid Java syntax. We could say var equals non-sealed. I wouldn't recommend this, but it is code that will compile and will work because, of course, var, as I said, was a restricted type. So you can still have a variable name of var, and non is an integer, sealed is an integer. What we're actually doing here is subtracting sealed from non, not using non-sealed as a keyword. Like I say, probably not a good idea to write that as code. Hidden classes introduced in JDK 15. This is a different feature to the way that sealed classes work because these are at the JVM level rather than at the language level. And the idea here is that there are situations with code that's generated at runtime where what we really want to be able to do is to hide those classes that are being used from other parts of the system. And invoke dynamic is the way that these things typically happen. If you look at Lambda expressions, this is a good example. You may have quite a complicated method with lots of code in it. And at one point, you're using a stream which involves Lambda expressions. In terms of the compiled code, those Lambda expressions will use invoke dynamic so that the runtime system will determine the best way to generate the code for the Lambda expression at runtime. That's all good and it works very nicely. But what could be good is to be more efficient in terms of the use of resources, is that you're only using that Lambda expression for a very small space of time. So rather than leaving it around for the whole lifetime of that method, what we could do is reclaim those resources after we've run the stream and be able to reuse those resources. But if we have that Lambda expression visible to the code, then potentially it could get used elsewhere. So what we do here is we make it a hidden class, and these things can only be accessed by a reflection. It's primarily intended for framework developers, primarily intended for the situations like Lambda expressions. Records. Again, now they've been introduced as a second preview. So we've had a couple of changes over things that we saw in JDK 14. Based on feedback, so first is that the fields in records are now truly, really final. You might think that by marking something as final, it means that its value is set once and can't be changed. But the case is that you can use reflection to change even something that is final. In the case of records, they've decided that isn't really very good, so they're making it truly final. Even with reflection, you can't change the value. Second thing they've done is to prohibit native methods from records, which you could have used before. The reason being that they thought that could introduce some behavior that would be dependent on external state, and they didn't like that idea. The other thing they did in records second preview was the idea of local records. And this is a really good use of it, because what they've done here is to say, okay, to be as effective as possible, let's allow a local record within a method. We can see an example here where we've got a method called find top sellers. So we're passing in a list of people who are selling things for us, And what we want to do is to generate a list based on who sold the most in a given month. And so what we'll do here is we'll pass in the month as well. And then we're going to use a local record, which is our effectively tuple, which contains the seller and how much they sold in a particular month. Then our stream code becomes a lot simpler because we can say, okay, let's create a stream, pass that into map to map the sellers that we have into our local records. So we get the seller, and then we calculate how much that seller sold in the month we're interested in. So now we've got the tuple with the seller and how much they sold. Pass that into sorted so that we can compare based on their sales, order the stream. So now we have the sellers based on how much they sold in that month, then map it back to the seller from the local record. So we then end up with a list of just the sellers. And that really simplifies the code by having the ability to use a local record. This is a very, very powerful change and addition to this feature. Other thing they did was to ensure that records could work with sealed classes. In this case, we're actually referring to interfaces because records, as I said, can't extend another class, but they can implement other interfaces. So we can create a sealed interface called car that permits red car and blue car, and then we can create records called red car and blue car, which implement car. JDK 16, so bringing us right up to date, just a few things about that. So pattern matching instance of. Important thing about this is now a final feature. So we've gone through the preview idea, and we're now making it a final part. It's in the Java language specification. You don't have to enable preview features to use it. A couple of minor changes to the way that it works. One was that they said that pattern variables, which were implicitly final, now are no longer so. So you can change the value of that variable. So in the case of our S, you could change the value if you wanted to. I think that's a good change because I didn't like the idea of having them implicitly final. I didn't see the logic behind that. And then the other thing they've done is to say that compile time error to compare an expression of type S against a pattern of type T where S is a subtype of T. You have to read that a couple of times to understand what it actually means. And the easiest way is to show you an example. If we had a method called print upper left colored point, which takes a rectangle as a parameter, and then we do if our instance of rectangle rect, print out rect, well, obviously that doesn't make any sense because we're passing a rectangle in and we're then saying is R an instance of rectangle? Well, it can only be an instance of rectangle. That doesn't make any sense. So you will find now that if you run that, I did it through JShell, it will say pattern type rectangle is a subtype of expression type rectangle, and it will reject that. A couple of other things that got added in JDK 16, Unix domain sockets. This is something that's been around for a long time. The idea of inter-process communication as it was done on Unix, which means Linux, which means Mac. The reason that this wasn't included in Java before was that Windows didn't support it until Windows 10. Now that everybody has Unix domain sockets, we can make it cross-platform and we can include it as an API as part of the standard. Works in exactly the same way as you would do a TCP/IP loopback connection. Behavior is identical, but it's better from the point of view of security, better from the point of view of performance. So now you can just create a Unix domain socket using a factory method, no constructor involved, and specify the endpoint as a file in the file system. Streams map multi. Again, a little change to the Streams API. When you read the definition of this, you immediately think it's just like flat map, because it says each element on the input stream is mapped to 0 or more elements on the output stream, which is exactly what flat map does. The difference is that you can actually apply a mapping at the same time. And the way it works is by using a by consumer. Again, just to give you a very simple example, we've got a stream of names of programming languages, pass it into map multi, 2 parameters. One is the stream input, the other is the consumer, which is where we're going to generate the output. And then what we can do here is we can have the number of characters in each word and print that the number of times there are characters in that word. Don't know why you'd want to do that, but it's just an example. So here we do a for loop and we use the length and we print out the length that number of times. The important thing to get here is that we can call the accept method on the consumer as many times as we like, and we can pass whatever we want to that consumer. So it's a way of just having the ability to construct different output for our streams. Vector API. This one is an Incubator module. So again, it's not part of the Java SE specification straight away. And it's not to be confused with the vector class, which we've had right from JDK 1.2 as a way of doing the collections, basic collections. This is about using vector operations at the processor level. Vector operations use very wide registers, single instruction, multiple data. You're processing an array of integers, for example, load them up into your very wide register, apply a single operation to them in one clock cycle. This is very good, very useful, but the problem is many compilers struggle to understand where they can use vector operations. This API allows you as a programmer to explicitly state how you want to use them. As an example, what we've got here is simply taking two arrays of floats and calculating a value into a third float array as a squared plus b squared times -1. All good. If we want to use the vector API to do that, the code gets a bit more complicated, but we can force the compiler into using vector operations. First thing we need is to understand what species of float vector we're going to use. In this case, it's going to be a 256-bit wide register. What that means is you do need to understand what hardware you're going to be running this on. So whether you're using a 256 or a 512-bit register, you need to know in advance. Now what we do is we take our method with our arrays and we use our loop again. But this time, what we do is we create a index into the range, so a species way of indexing into the register that we're using so that we can populate the individual elements there. Then we create float vectors from the arrays using that species and using the way that we want to populate those vectors. So it's essentially taking the elements out of the float array and putting them into the very wide register. And then we do the same thing for our B array. And then what we can do is we can calculate the result into another float vector as part of the vector API. So we say VA multiplied by VA to give us A squared, add VB multiplied by VB to give us adding B squared, and then negate that. Then you can extract the elements out of the vector array into the results array C and return the results. A bit more code, but it does give you the power of being able to control this in quite a fine-grained way. For a memory access API, this is part of a replacement for Sunmisk Unsafe, and it's also part of the Project Panama, the ability to access native code more easily from Java. So this was introduced back in JDK 14. It's now in a third incubator iteration. What it does is give you a safe way of accessing memory outside of the heap. You can do that through a memory segment, which is essentially a pointer to an area of memory. You've got a memory address, which is a pointer to a specific address in memory. And then you've got a memory layout, which is a way of describing programmatically what's stored in your memory segment. So just to give you a couple of examples of that, you can use allocate native on a memory segment. Let's say here we want to allocate 100 bytes, very similar to doing malloc in C. And then what you would do is you could loop through 25, use memory access, set the int at a particular offset into that memory area, but you have to calculate the offset, remembering that each int has 4 bytes in it. So you calculate that as I times 4. Using a memory layout, we can make that slightly easier to avoid having to do the indexing ourselves. So we create an int layout with 25 ints in it. We're going to use 32-bit ints, and we're going to use the native order of the underlying platform. We don't care whether it's most significant bit or least significant bit. Then we use a var handle that was introduced a while ago to index into that area of memory that we've got, so our layout. And then we can just have our block here where we do create an area of memory that we want to use, allocate native, and then we can go through that and we can populate it with our values, but we don't have to use the calculation ourselves. We can just use the var handle, and that all works automatically. Also related to this sort of foreign linker API, this is using local or remote libraries. And again, part of Project Panama. Initially, this is targeted at C code. C++ should follow at some point. simple example here where we want to use the getPid method call, or function call, I should say, in the standard C library. What we do here is we say, okay, we need to get reference to the linker, the C linker. So we do that through a factory method. Then we need to be able to look up the function within the library. And in this case, we're going to use the default library, which is all the libraries that the JVM has access to. If we had an external library that we wanted to use, we could do that through a file name or whatever. And then we need to get a handle to be able to call that function. And we use that in terms of a down call handle. Down call handle is when we're calling to that particular function. There's also the up call handle, which is if you have a callback from a native method, a native function into a Java method. So in this case, we're using a down call handle, looking up the getPid function. We then get the reference to that. We know that that will return an int value as a C int value, and we then need to make sure that's converted into a Java int value, and that will then be returned. So in this case, we can print out getPid, invoke exact, it's an int, and it all works. One thing I would say is that as part of Project Panama, this will have the JExtract command, and that makes this so much simpler. All that code above the print line statement disappears. You use JExtract, you end up with a static import on getPid, and then you just call it, and it all works really nicely. Project Panama is looking very good. A couple of last things. Warnings for value-based classes. This is part of Project Valhalla, which is all about adding value types to Java. What they said back in JDK 9 as part of this was that they were going to deprecate the constructors on the primitive wrapper classes, integer, float, short, and so on. These have been designated as value-based classes to support the work of Valhalla, and so now what they are is marked for removal, meaning that in JDK 17 we'll probably see the removal of the constructors on these. You shouldn't be using them anyway, and also if you attempt to synchronize on an instance of a value-based class, you'll get a warning for that as well. Last thing to mention here for JDK 16 is that they have changed the default encapsulation for JDK internals. This is the illegal access flag that we had introduced in JDK 9, so that we could still use things like sunmisc unsafe if we wanted to. The default for that has been up until now permit. It's now set to deny. So that will remove the ability to access certain internal APIs. The critical internal APIs, of which there are 6, are still not encapsulated yet because there aren't public versions of those, so sunmisc unsafe is still accessible. Just to summarize then, so we can get to some questions. One thing I will say, because I work for Azul, is that we have a build of OpenJDK. It's called Zulu Enterprise, and we support all sorts of different versions all the way back to JDK 6. We have 7, we have 8, we have 11, we have 13, and I should also add 15 because we support that as one of our medium-term support releases. We backported TLS 1.3 and Flight Recorder into JDK 8, so people could use those. There are free versions for Intel 64-bit Windows, Mac, and Linux, Intel 32-bit versions of Windows and Linux, and there's also ARM, PowerPC, MIPS, and so on. It is very much a drop-in replacement for Oracle JDK. You can just replace Oracle JDK with Zulu. Everything will work in exactly the same way. To conclude then, 6-month release cycle is working very, very well. I really like this. And you can see, looking at JDK 12 to JDK 16, lots of great new features, lots of these preview features, gradually making it into the full language, but doing it in a way that enables feedback and people can actually say, we think that should be changed. Get ready for JDK 17. That is the next long-term support release. That will be out in September. And what I would very strongly recommend is testing your code with JDK 16, so you've got the minimal set of changes when you move to JDK 17. And if you're wanting to deploy into production a build of OpenJDK, I would thoroughly recommend Zulu as an alternative. Questions? Okay, so if I go to, let me see if I can go to the Zoom call. On the Zoom call, yes.
No need to go to the Zoom call yet.
Okay.
We will take a few questions right now. So Timur, feel free to start.
Okay, thanks. First of all, thanks.
Good.
I can
hear you. I can hear you, yes.
Well, first of all, thanks for your fabulous presentation. And there is a question from our chat. The question is about how Java runtime understands the context of null pointer exception. Could you please shed the light on it?
How does it? Well, so a null pointer exception is thrown when you try to access something as an object reference, and the object reference hasn't been set. It's one of those things in terms of programming languages. A lot of discussion about this as to whether you should actually have null references or not. Some languages don't include the concept of that, so you can't actually have a null reference. But Java is a language that you can have a null reference, and what that means is that you can create a variable, and you can say, okay, I've got variable X, which is a string, for example, and you can say, I don't know what it is yet, so I'll make it null. And then at some point later on, I will assign a value to it and be able to use it. But the problem is if you assign null to that variable, and then at some point later on, you try to reference it, and you try to use like length on that, what will happen is that the virtual machine will say, right, you want to call the length method on that string, but the reference is null. Can't do that because there isn't an object to call the length method on. There is no length. So it will then throw a null pointer exception to indicate that you've tried to reference through a null pointer, and that stops your application abruptly. It's one of those things that happens a lot in Java code. I see it all the time. Well, not all the time. I see it frequently in code I work on, and other people will see that as well. And as I said, one of the key things is when you chain together references, it can be hard to see where was the null coming from, because if you just had a equals 5 or some reference, whatever, then you can see immediately, okay, that's the line where I've got a null reference. But if you've got things chained together, it makes it harder to see. So I think that's probably the simplest answer to that question.
Well, and do you know how exactly JVM stores the information? What exactly reference in the chain of references is now?
Oh, I see. Well, it doesn't actually need to. The way this feature works is it's not changed substantially any of the code in the JVM itself, because the JVM always maintains those references. So object A will have a reference to object B because it's part of the structure of that class. Object B, because of the structure of that class, will have a reference to object C, and object C has a reference to I. So all of that, it doesn't change at all. What's happening is simply that when the JVM follows those chain of references, when it hits a null pointer, so in the case of my example, it couldn't reference C because A.B was null, then it says, rather than just printing out, okay, we hit a null pointer, that's it. It says we hit a null pointer, and the point at which we did that was when we got A.B. So it just gives you more information about what's already happening. So as I say, there's not really any fundamental change to the way the JVM works. It's just a more useful error message.
Makes sense.
Okay. So, and I would like to ask you, what's your favorite feature that appeared in recent versions of Java?
Yes. So I did say that null pointer exception is my favorite feature, but I actually think really records. Null pointer exception is good. It's handy, but from a programming point of view, records is definitely the big thing that really does make life so much easier. I've seen a number of examples where the code that you can create becomes way, way simpler, but not losing any of the readability. And that's the key thing. Making the code shorter is one thing, but making it readable still is very important. And so the ability to have records, simple data classes, without having to create a whole set of code for an individual class. You don't even have to have type pollution by creating lots of extra classes. You can do, simply have a local record. Very, very nice. Works really well. That's definitely my favorite feature.
Okay, so we have got another couple of questions from chat. The first one is about sealed classes, and well, if it is a mandatory feature that once we define a sealed class, we need to know, we need to define all the children of the sealed class. For example, if it is possible, in your example, when you defined different shapes, you mentioned that there are triangles, for example, rectangles. If it is possible, just to mention rectangle, but not to define it.
Oh yes, yes. You could easily have in your list of classes rectangle, but there is no definition of rectangle anywhere. That's perfectly acceptable, because you're saying that there is the possibility that a class called rectangle can inherit from shape, but you don't have to define it. But if it is defined, then its inheritance structure must also be defined, as I said, of one of those three things. So either it's final, it extends further the sealed class, or it's unsealed by using the non-sealed keyword. Or so there's no requirement to implement all of those classes that are listed in the permits clause.
Another question is about pattern matching and records. Will pattern matching work with records?
Yes, so this is something that is being proposed. I think it's JET 403 or 404. I'd have to go back and have a look. But it is one of the things that they're looking at, is an extension of the way that pattern matching works onto records, and doing some interesting things with that. So it's worth having a look at the newer JEPs on there, because that contains a lot more information on how that will work. And again, it's a very powerful looking feature that will simplify code very nicely in terms of how you can do that.
Cool. I do have one from myself as well. After introducing new contextual keywords, and especially hyphenated contextual keywords, did the front end of Java undergo any significant changes to support them?
I don't think so. I think it was more sort of a fairly technical change. I must admit, I haven't looked at all the code of how that works on the compiler front, but I don't believe it required a lot of complicated changes.
All right. Then thank you so much. It's been really great having you. Even though I already saw the slides, I was really happy to watch the whole thing. And now I invite you and Timur to the discussion zone to chat with the audience further and ask any questions. Let's go.